I'm Denis Rancourt. I'm a former tenured full professor of physics. I'm an environmental scientist, and I'm presently a researcher at the Ontario Civil Liberties Association. And today I want to tell you about some inconvenient science that is simply not talked about in the mainstream media or by government officials in relation to COVID-19. And the first point I want to make is that there was very recently this year in Lancet, Verity et al. Published an important summary of what the fatality rates are for this disease. This is a picture of the cover of that article, and you can see this graph here is very important because the case fatality rate is near zero until you get up into the 60 and over ages, and then it goes up like that. So the case fatality ratio or rate, which is also related to the infection fatality rate. Both of these rates are low, are exceedingly low for young ages, for anyone who is middle-aged or going towards children. It's low. Now that's inconvenient because this is not. It means that this is not such a virulent disease. Now this is true unless it is very contagious. So the measure of contagion, and that's where the other part of the inconvenient science comes from. The measure of contagion is the so-called reproduction number. So the reproduction number is how many people on average, typically one infected person will infect. How many others will they infect? Will that one person infect? So there's a lot of talk about this ratio, and there's a lot of various simulations and calculations that are done to estimate the ratio. But the problem is, none of this work that you can see in the public domain, all of it ignores some inconvenient research, which is a landmark study that was done in 2010 by Shaman et al., and that was published in PLOS Biology. This is the cover page of that article in PLOS Biology. And what this article found is that it was able to, for the first time, explain in very convincingly with data and simulations to understand that data, what causes the seasonal variations in these viral infection of the respiratory tract and the extra mortality that is associated with those. What causes this large seasonal change in temperate latitudes? And what they found, so this has been a puzzle to understand, how influenza works and why it's seasonal and so on. This has been a puzzle for a long time in the science community, but these guys, Shaman et al., solved that puzzle in a definitive way. They found that it was due to air humidity. In other words, the absolute humidity in the atmosphere is what is such that if it's dry, the droplets that are carrying the virions or the viruses will shrink very quickly and will become aerosol particles that are maintained for a long time in the air that can be easily breathed in, that will get in through that will travel easily everywhere, and that will be carried by the atmosphere without being gravitationally settled or deposited if they're small. So the dry air makes the droplets small so that they're everywhere. They're a cloud, they're a fluid cloud that you breathe in, and that makes it very infectious. Whereas if air humidity rises, then the big droplets stay big, and the small droplets grow by condensing water on their surfaces, and the bigger droplets therefore very quickly gravitationally settle and are taken out of the atmosphere so you don't breathe them in. This is the mechanism that drives how contagious these diseases are, the seasonality of the contagion. And the basic reproduction number can vary fourfold over the course of a season because of this effect. So it's a gigantic effect. So when you see the reviews of basic reproduction numbers, they like to characterize a given strain of a given virus and give it a constant number. But in fact, it's not constant at all. You have to look at the mechanism. You have to understand how this is occurring through these aerosol particles, and that reproduction number varies fourfold over the course of that seasonal cycle. That means that something that during the summer is not particularly virulent and that will live in our bodies and in the environment, then come winter, when the air dries, that very same pathogen will become exceedingly virulent. And that is why the virulence or the contagion level is going to drop. It's going to drop irrespective of whatever else we do, because this is a major effect. A fourfold change in that reproduction number is a major effect. So it's going to drop. And I hope that we won't say that it dropped because of all these mitigation measures, because that would probably be false. And then it's going to, these very same viruses are going to become contagious again in the next dry season, dry air season, the next winter. They will fire up again, the so-called second wave. Well, now we understand that. We understand the biology and the physics of it. So these little droplets, one single droplet carries the minimal infectious dose. Hundreds of viruses are in one of these very tiny, less than 2.5 micron diameter particle droplets that are aerosols that don't settle. So it will get through any space between even a highly filtering mask. They go everywhere. It's part of the fluid, and that's why it's contagious. So this is inconvenient science, breakthrough science that now allows us to understand how virulence and contagion of these viral infectious diseases of the airways, how they operate. We know this now. Why is this science not being admitted, discussed everywhere? How can we even talk about a reproduction number as though it were a constant when it has this dramatic, it's dramatically influenced by air humidity in the season that you're in. So that's my message for today, is that there's basic science that we're ignoring. In conclusion, the COVID-19 is not particularly fatal in terms of the actual number, except if you have a co-condition as an older person, and it is not particularly contagious either, and that contagion will vary dramatically with the season. That's all there is to it. That's it.